Welcome. We are discussing about the radioactivity. In previous lecture, we discussed about the half-life period. The time required by radioactive substance to disintegrate half of its original value is known as a half-life period. Friends, in this lecture, we have to see what is mean life. The ratio of total lifetime of all atom to total number of atom is known as mean life, and therefore mean life, which is denoted by tau, mean life, which is denoted by tau, it is equal to the total lifetime of all atom to total number of atom. Okay, the ratio of total lifetime of all atom to total number of atom is known as mean life. We know that the n is a number of atom or radioactive nuclei present at instant t. N is the number of radioactive nuclei present at a time t. Dn is number of radioactive nuclei disintegrate in a time t plus dt. Okay, Dn is a number of radioactive nuclei disintegrate in a time t plus dt. Okay, now from this we can say that the lifetime of Dn atom, lifetime of a Dn atom of Dn atom, it is equal to T into Dn. Okay, now the total lifetime of N0 atom, N0 is the number of radioactive nuclei when time t is equal to 0, and therefore total lifetime of all atom, total lifetime of all atom, it is equal to integration of 0 to infinity t into dn. Okay, total lifetime of all atom, it is equal to integration of 0 to infinity t into dn. Okay, lifetime of dn atom is equal to t into dn. Okay, now we know that when time is equal to t0 or when time is equal to t is equal to 0, the number of radioactive nuclei n is equal to n0. So n0 is a total number of atom. Okay, the disintegration of a radioactive nuclei start from t is equal to 0, and therefore total number of radioactive nuclei or atom at a time t is equal to 0 is a n0, and therefore we can say that tau is equal to, that is a total lifetime of all atom, it is integration of 0 to infinity t into dn divided by n0. n0 is a total number of atom. The disintegration of radioactive nuclei start from the radioactive nuclei n0. Okay, and therefore we can write like this. According to law of radioactive decay, we know that n is equal to n0 e raised to minus lambda into t, And therefore we can say that the radioactive nuclei disintegrate exponentially with the time. Radioactive nuclei disintegrate exponentially with the time. N is equal to n0 e raised to minus lambda into t. We also know that the rate of disintegration is directly proportional to the number of radioactive nuclei present at that instant, and therefore if we consider magnitude only, dn upon dt is equal to lambda into n. Okay, dn upon dt is equal to lambda into n, and therefore dn, it is equal to lambda into n into dt. Okay, but n is a n0 e raised to minus lambda into t, and therefore we can write dn, it is equal to lambda into n0 e raised to minus lambda into t into dt. Okay, this is dn. If we consider this is equation number 1, okay, putting this value in equation number 1, we get tau is equal to, that is the mean life, tau is equal to integration of 0 to infinity t into dn. Value of dn is a lambda n0 e raised to minus lambda into t into dt divided by n0. Okay, this n0 get cancel, and therefore tau is equal to integration of 0 to infinity t into lambda e raised to minus lambda into t into dt. But here the disintegration constant lambda is a constant, and therefore taking out from the integration we get tau is equal to lambda into integration of 0 to infinity t into e raised to minus lambda t dt. Okay, now we have to solve this integration by using parts. Okay, integration by using parts. Okay, by using parts, we know that integration of a u into v dx by using parts, it is equal to u into integration of a v minus integration of u dash in bracket integration of v, okay, dx into dx. Okay, so this is formula for integration by using parts. So here we consider u is equal to t and v is equal to e raised to minus lambda into t. Okay, and therefore we get tau is equal to lambda. Okay, here we can take square bracket when we solve the integration, t into integration of e raised to minus lambda into t into dt, okay, minus integration of u dash, u is a t, so it is equal to dt upon dt, okay, integration of v means integration of e raised to minus lambda into t into dt, okay, into dt. The integration is from 0 to infinity, okay, 0 to infinity. Okay, here is also 0 to infinity. Here is a 0 to infinity. Okay, now therefore tau is equal to lambda integration t integration of e raised to minus lambda t. It is e raised to minus lambda t divided by minus lambda. Okay, minus here when we solve this integration of 0 to t dt upon dt, here is a okay. When we solve all these terms, we get this is integration of minus lambda t divided by, here is a minus lambda square, okay, and from 0 to infinity. Okay, now when we put value of a t is infinity and 0, when we put value of a t as infinity, this term became 0, this term also became 0. When we put value of t as 0, this term became 0, but here this term is tau is equal to lambda in bracket e raised to minus lambda into 0 divided by minus lambda square. Okay, here is a minus minus, it became plus. Okay, now this minus lambda into 0, it is a 0, e raised to 0 is a 1, this lambda into minus and this minus became plus, and therefore tau is equal to lambda into 1 upon lambda square. This get cancelled, and therefore tau is equal to 1 upon lambda. This indicates that the mean life of a radioactive substance is a reciprocal of decay constant or disintegration constant. Okay, now we know that the half life of a radioactive substance is t is equal to 0.693 divided by lambda. This is a formula for half life, and therefore we can say that t is equal to 0.693 into tau. Okay, 1 upon lambda is tau, that is a mean life. Therefore we can say that tau is equal to t upon 0.693, so it is equal to 1.44 into t. This gives relation between mean life and half life. Okay, tau is equal to 1.44 into t, that is a half life period. Now we know that the n is equal to n0 e raised to minus lambda into t. That is, according to law of radioactive decay, n is equal to n0 e raised to minus lambda into t, multiplying both side by lambda. Okay, multiplying both side by lambda, we get, okay, n into lambda, it is equal to n0 into lambda e raised to minus lambda into t. Okay. So this can be also written as n into lambda divided by n0 into lambda, it is equal to e raised to minus lambda into t. Okay. But here n into lambda is the activity of a radioactive substance at a time t. So we can say that A is equal to n into lambda, while A0 it is equal to n0 into lambda. A0 is a activity of a radioactive substance at a time t is equal to 0. Okay. So this can be written as A upon A0, it is equal to e raised to minus lambda into t. Now the time t is considered as 1 upon lambda. This time t is mean life of a radioactive substance. It is also considered as a tau, and therefore we can say that t is equal to tau and it is equal to 1 upon lambda, because tau is equal to 1 upon lambda. Tau is equal to 1 upon lambda, and therefore we can say that A upon A0, it is equal to e raised to minus lambda into 1 upon lambda. This lambda lambda get cancelled, and therefore A upon A0, it is equal to e raised to minus 1. So A upon A0, it is equal to 1 upon E, and when we put a value of a E, okay, then we get A upon A0, it is equal to 0.368, or simply we can say that A upon A0, it is equal to 36.8%. Okay, 36.8%. And from this we can say that mean life is time required for activity of a radioactive substance became or disintegrate 36.8% of its original value or initial value. So the mean life is the activity, mean life is a time required by radioactive substance to activity of a radioactive substance became 36.8 of its original value, or simply we can say that A is equal to 36.8% of A0. So the activity of a radioactive substance is decreases, and it became 36.8% of its original activity. A0 means activity of a radioactive substance when time t is equal to 0. So this is related to mean life. Okay. Mean life is a ratio of a total lifetime of all atom to the total number of atom. Okay, and therefore tau is equal to total lifetime of all atom divided by total number of atom. If we consider n is a number of radioactive nuclei present at a time t, then dn is a number of radioactive nuclei disintegrate in a time t plus dt. Okay, and therefore we can say that the lifetime of a dn atom, it is equal to t into dn, and total lifetime of all atom, it is equal to integration of 0 to infinity t into dn. But we know that the when t is equal to 0, n is considered as a n0, that is the number of radioactive nuclei are n0. Again we can say that tau is equal to integration of 0 to infinity t into dn divided by n0. But according to law of radioactive decay, n is equal to n0 e raised to minus lambda into t, and dn upon dt is equal to dn upon dt is equal to lambda into n, and therefore we can say that dn it is equal to lambda into n into dt. Therefore dn is equal to lambda into n0 e raised to minus lambda into t into dt. Putting this value in above equation, we get integration of 0 to infinity t into lambda into n0 e raised to minus lambda into t into dt divided by n0. n0 get cancel. Okay, then taking lambda outside the integration, and by solving the integration by parts, we get the lambda is tau is equal to 1 upon lambda. That is, mean life is a reciprocal of a decay constant or disintegration constant. We know that the half-life period of a radioactive substance is 0.693 divided by lambda, but 1 upon lambda is equal to tau, and therefore we can say that tau is equal to 1.44 of a t. This gives the relation between the mean life and half-life. Again we know that n is equal to n0 e raised to minus lambda into t. Multiplying both sides by lambda, we get lambda n into lambda is equal to n0 into lambda e raised to minus lambda into t. But activity of a radioactive substance at a time t is A is equal to lambda into n, and activity of a radioactive substance when time t is equal to 0 is A0 is equal to n0 into lambda, and therefore we get A upon A0 is equal to e raised to minus lambda into t. Here we consider time t, it is equal to mean life, and it is a reciprocal of a decay constant, and therefore putting this value we get this. So A upon A0 is equal to 1 upon E. Putting value of E, it is I think 2.718. Okay, and reciprocal of a 2.718, it is 0.638, and therefore A upon A0 is a 36.8% of 36.8%, or simply A is equal to 36.8% of A0, and therefore we can say that mean life is a time required by a radioactive substance to activity of a radioactive substance became 36.8% of its original activity. Okay, so this is related to mean life. In a next lecture we have to see what is a specific activity. Thank you.